Okay, in this video I want to take you through a few examples using some of the facts from the previous video. So hopefully you've had a chance to review some of the ideas that were in that video's content, including things about protons, neutrons, electrons, atomic number, and mass number. And then a little bit at the end about how we tell atoms from ions, or some of the key differences between them. At the end of the video you saw a way of sort of showing what we call atomic symbols or elemental symbols. And the format here is kind of reviewed in this corner. This isn't on the page that you would have gotten in class, but it would have been from the previous video. And this just kind of reminds you where everything goes. So in each picture that we'll consider, or each symbol that we'll draw, the mass number will be in the top left corner. So that's common in both of these pictures. The atomic number will be in the bottom left corner, and that's a key piece of information for every element. And then the charge would be in the top right corner. So as we look at the top right corner in our first picture, we do have a charge of +2. In the second picture, we don't really have a charge shown there at all. So that would imply a charge of 0, which doesn't need to be shown, but is sort of understood or assumed to be the case when no other number is given. And then, of course, in the middle is the abbreviation for the element, which comes right off of our periodic table. So that's kind of what we're up against as far as some of the symbols that are here. These two examples, and some of the ones that we'll be doing then together. Now, we've got, right away in the first picture here, this particular sample that you see is going to be the same one that's here on the first row of the homework page that I've given you in class. And again, if you don't have this page, you could screen capture this and fill it in, or do whatever you like, or just kind of listen along and fill it in later on. But we're going to just go through a few examples. On this video, we're going to work through number 1, number 2, and I think we're going to do number 8. So we'll work through those 3, and then I'll let you work on the others, and we can check your progress when we get back together in class. So to identify PD, our element here, that's one place to start. We're going to go to the periodic table and look it up. If you don't know where they all are, you're like most people at this point in the year, so you may have to hunt around a little bit. But to help you out on this one, I'll show you that PD is kind of right here near the middle of the periodic table. It's element number 46. And that atomic number 46 is going to be a key piece of information, because right there is that atomic number that we're going to use to start out some of our work here as well. And then the element that we're talking about is palladium. So palladium, the element's name, is given to us right here. Okay, so let's take that information for PD over to the page and put it into the spots where it belongs. So the element PD, again, palladium, by name. I'm going to go ahead and fill that in here. Let me switch to a little thicker pen, make it a little bit easier for you to see things. Palladium. And then the number 46 we said was its atomic number, and that was given there on the periodic table as the key prominent information for the element, number 46. Now, if you don't know on this particular print version of the periodic table what each piece of information is, again, that top number right there we said was the atomic number. And how do I know that? Well, I can look at that little key down in the corner of my periodic table and dig it up there too. So down here in the corner, if you're not remembering where everything is, or don't know on this particular layout what to find where, there we find atomic number hiding out right here in the top corner. It's that first thing they show us in the upper left on this particular version of the periodic table. This is the Flynn periodic table, and it's the one that we'll use in the class throughout the year. This table gives us the atomic number, it gives us the abbreviation, 1 or 2 letters, it gives us the name of the element, and it gives us a bunch of other information, some of which will be important at some other points later in the class. So for now, that atomic number 46 for palladium, something we can fill in along with the name in our table. And then we're off to the races really from there. So what do we know next? Well, remember that atomic number tells us the number of protons in any element. So when I know the atomic number, I automatically know the number of protons has to be the same. That's 46, because atomic number equals the number of protons. Mass number. Remember, the top left corner is a number that tells us the mass number. So for this particular atom of palladium, or ion of palladium, we've got a mass of 108. Now that's 108 AMUs, but we're just going to put the number down for our work here. Is this an atom or an ion, the question says next? Well, because it shows a charge in the top right corner, we can assume that this is an ion, or we know that this is an ion. It's an ion because it has a non-zero charge, and it has a charge listed of 2+. So I'm going to go ahead and put that in, just kind of pulling all that information off of the symbol that was given. Now, what's next? We can do neutrons or we can do electrons. Either one of those would be okay. Let's take a look at neutrons first. Remember that mass number is protons plus neutrons. All right, mass number, which we've figured out already here to be 108, is equal to the number of protons plus the number of neutrons. Well, from here, it's just basic arithmetic. 108 is the total of protons, which we know to be 46 from our atomic number, and neutrons. Well, if we rearrange and we subtract 46 from each side, subtract 46 here, subtract 46 here, that'll be gone, and my neutrons will be 62. Okay, how many neutrons then? That's the total between protons and neutrons to get us to 108. So 62 neutrons plus 46 protons will get me a total mass of 108 for my mass number. Now, as far as electrons go, the last little piece of information to put in there, we're going to figure that out using the charge and the protons. So charge, protons, and electrons are all linked to each other. Just to kind of set this apart, I'm going to switch over to a different color for the purposes of this last part. Remember, charge is a balance of protons and electrons. One simple way to kind of figure out charge is to say that charge is equal to the number of protons minus the number of electrons. It's not a real official way to think about it, but mathematically it works out. And we'll show you how with this one. The charge is telling us in this problem is 2 plus. All right, protons I know are 46 because that comes from the atomic number. And I don't know how many electrons yet. So basically it's a question of 46 minus how many electrons would give me an overall charge of 2 plus. 46 minus what gives me 2. Is kind of the idea. And in the end, that would have to be 44, right? That would have to be 44 electrons if I'm going to have a charge overall of plus 2. 44 electrons. Now I'm going to look at it another way. Okay? Think about protons and electrons as sort of a stack. If I've taken all the protons from my palladium atom, stacked them up, I'm taking all the electrons from my atom and stacking them up next to the protons, and I'm going to figure out which pile is larger, basically. If I have 46 protons and I have 44 electrons, those stacks are not equal in size. I'm going to have a slightly larger size, I'm going to have a slightly larger pile of protons than I will of electrons. And those two sort of extra protons, each have a positive 1 charge. And so 2 extra protons would give me a 2 plus net charge. If those two numbers were equal, then I'd have a 0 charge. If I have a neutral atom or a neutral particle. In this case, because there are 2 extra protons, or I have a plus 2 charge, that plus 2 charge is due to the fact that there are 2 more protons than there are electrons in this example. Sometimes it's a little counterintuitive, but other times, as soon as it clicks, and it doesn't happen right away, but once it happens, it clicks pretty easily, and hopefully this will become kind of an automatic idea. Protons, electrons, and charge will probably be the one part of understanding and getting used to these subatomic particle and mass and atomic number relationships to start us out in this unit. That'll be the trickiest little bugger to get it kind of mastered and just become automatic. But once you do, you'll wonder how it ever was tricky. Now let's look at another one. Let's look at number 2. I've been given some pretty important information right away here. They gave me different information on question 2 than they did on number 1. They said that I've got an atomic number of 74. Now they've also mentioned in this question that there's a charge of 5 plus and that there are 109 neutrons. All that's going to be important, just not right away. Now I could take that atomic number of 74 and do a couple things with it. I can automatically fill in my protons, right? Because I know that atomic number 74 means there has to be 74 protons. Because protons and atomic number, again, are equal. Okay? Now I can also go to my periodic table and find out what element this is. So atomic number 74, go over here to your periodic table, find element number 74, and here it is. One of my favorite elements, tungsten. So tungsten has an atomic number of number 74. Right up there in the top corner again, that atomic number 74. So that's how I know we're talking about tungsten in this problem. So I'm going to go ahead and put tungsten in to my table as the name of the element. There we go. And its symbol will start with an abbreviation of W for tungsten. Now, what else do we know? remember the bottom left corner of that symbol will include the atomic number, and I've already got that. I was given that in the original information. So 74 goes down there as the atomic number. I was also given the charge, which is said to be 5 plus here. So this charge of 5 plus needs to go up in the top right corner. And that leaves me for my symbol just one more thing to figure out, and that's going to be our mass number. And we'll get to that here in just a second. Now, I also know that because I'm given a charge of 5 plus, that this is not a neutral atom. In fact, with a charge of 5 plus, it's an ion again, just like the last one that we did. And it's a positive ion. A positive ion has more protons than electrons, just like in the last problem. 2 plus in our previous question meant there were 2 more protons than there were electrons. 5 for our charge here, 5 plus means there are 5 more protons than there are electrons. So there are 5 more protons than electrons. I can relatively easily, hopefully, go ahead and figure out that 5 more protons would mean there would have to be 69 electrons. My pen got a little thin again, pardon me. 69 electrons. Because again, that imbalance of 74 positives and 69 negatives, 69 negative electrons, right, and 74 positive protons will give us that default kind of charge then, or overall net charge rather, of 5 plus. These additional protons, they are winning the battle of protons versus electrons, and that gives me a 5 plus overall charge. Now, I'm not going to use electrons to figure out my mass number, but I did have to fill that part in. To figure out mass number, we're going to go ahead and combine the things that we did before. Right up here, we've got it, right? Mass number is protons plus neutrons, and we happen to know both of those things already. Protons are 74, neutrons are 109. Feel free to go to your calculator and punch that in, add it all up. 109 plus 74 gives me a grand total of 183. My mass number is 183 AMUs for those protons and neutrons, and therefore 183 goes in here as my, slipping around a little bit, 183 for my mass number in the symbol portion of my table as well. So there we go, tungsten completed. We kind of launched from that atomic number as the key piece of information that gave us protons, that gave us the identity of tungsten, that gave us its abbreviation as a W, and from there we used that proton number to figure out both charge and mass number. So protons was really important. Once you've got that, you can jump in and go almost anywhere. Now we've seen 2 ions. Let's jump down the page a little bit and look at number 8, where we're given the fact right out of the gate that number 8 is talking about an atom. So an atom means it's neutral, right? That's a big difference from what we've been doing up to this point in those other examples where we did have a charge. And atoms, spoiler alert, atoms are a little simpler than our ions to consider the particles for the most part. So for an atom, we're going to go ahead and say it's got a charge of 0, because for our purposes, atom means neutral. And if it has a charge of 0, that means it's neutral, means it has the same number of protons and electrons. Protons and electrons have to balance each other out. So if I have 43 protons, like I'm told in this page, that means I've got 43 electrons too. Those two things are equal to each other. That gives me that overall net charge of 0. Now, what element are we talking about here? 43 protons, right, means I've got an atomic number 43. And I should be able to go to the periodic table then, find element 43, and move forward from there. Kind of right here near the middle of the periodic table again is this element number 43, which looks kind of funky and hard to say. It's pronounced technetium. And technetium is one of the first sort of synthetic elements that were created in the lab, and it filled in kind of an empty pocket here in the middle of the periodic table where there wasn't a known element in that position until they made it in the lab way back when. It doesn't matter that we know that little bit of trivia about the element, but there it is, technetium. The name comes sort of from the idea of technology, that we created it using human technology, and it wasn't just naturally made by the combining of smaller atoms, like most of the other elements that are naturally occurring have been found to be made when those atoms combined, and protons and electrons and neutrons came together way back when the universe first created. So we're going to need to use technetium as our element here on question number 8. So there's that spelling and that abbreviation. We're going to need to bring that over then to the table and fill it in for number 8. Technetium. Tricky spelling. It's like a spelling bee word. I'll go with it right there. And it was TC. Okay, so fill that much in, and we're ready to go then. We won't need our periodic table for anything else on this particular row. Now what's left? We've got a mass number to figure out. Well, we can do it. Mass number has to be protons plus neutrons again. So I'm going to combine my protons, which were 43, and my neutrons, which were 56. 43 and 56 makes 99. So 99 is my mass number, and that goes in for the mass number column. It also goes into my symbol box in the corner here for mass number. My atomic number, 43, drops in down here in the bottom left corner, and I don't need to show the charge of 0 in the top right corner. It's assumed that that's the case. Again, when the charge is 0, you don't need to write 0. It wouldn't be wrong to put a 0 there in the top right corner, but it's sort of extra clutter, and we don't typically show 0 charges unless we're looking at some very specific things later in the course. So again, we show charge here for ions only. When that's left out, as was the case originally here for my antimony, that would imply a neutral atom. So is the case also then with technetium on number 8. We don't need to show the 0 there, and this one's done as well. Now we could take one step further with these. I don't require that you do it, partly because this page is meant to kind of leave some things for you to figure out and some stones for you to turn over. But in truth, if you want to get right down to it, we could get in here and go ahead and actually include the mass number along with the names like we showed you in the previous video. So this first one, on number 1, we could have called it palladium 108, right? So we could name it that way. Now I didn't leave you a very wide box, so unless you have a very small penmanship, it might be hard to fit that in there. But we could call this tungsten 183 because that's its mass number. And remember, that's that format that we use to show what kind of palladium, what kind of tungsten we're talking about in terms of its mass number. We could call this technetium 99. If you choose to do that, you can certainly do that as we go. You don't have to on this page, but just kind of getting into your head how we use that mass number as part of its name. Final clarification, I've had students make mistake about this before. When we write it as palladium 108, for example, that is not meant to say negative 108. That's just a name, right? Palladium dash 108, tungsten dash 183. That's not saying negative 108, negative 183. It's just there to link the name to that mass number and let you know that we're talking about a single thing, tungsten 183. It's a way of linking the name to the number. It's not a negative symbol. Okay. Tell you what, there's a bunch left on this page, and none of them is any tougher than the 3 that we've gone through together so far. So take some time before I see you next and work through the rest of this page. Unless I told you something other than that in class, your assignment is to finish this page up based on the examples that you've seen here. And if you run into one that you're not quite sure how to get started on, skip it. Go on to another one. Okay. One final hint I'll give you is there is a funky kind of thing you'll notice as you work through these. If you get into them a little bit, there is a little funky kind of uniqueness in numbers 9 and 11. Those two might kind of make you scratch your head a little bit. I'll leave it to you to figure out why when you get down to 9 and 11. But other than that, this page is pretty predictable based on the relationships that we've talked about here. Until I see you again, thanks for your hard work and for listening, and we'll talk to you the next time I see you.